Nuclear technologies can be used to eradicate insect pests. Insects are responsible for 10% loss of the total harvest in the world. This is equivalent of losing the entire harvest of a country as the United States of America. We all know that there are traditional methods that can be used to eradicate insect pests, like insecticides and pesticides, but these chemical compounds are very toxic and can cause problems in the environment and in human health. In addition, insects developed resistance to insecticides and pesticides, reducing their efficacy. Since 1950s, it was clear that new strategies needed to be developed to fight against insect pests. In this context, the Sterile Insect Technique was developed. This technique consists in the mass rearing of pupae and larvae of the insect to be eradicated. The insects are sterilized by exposure to ionizing radiation, either X-rays or gamma rays, before they are released by air over defined areas, where they mate with the wild insects, but no offspring are produced. This way, the number of insects in the pest progressively decreases until the pest is eradicated. It takes some time to completely eradicate the pest, but it is a very effective technique. The sterile insect technique has very interesting characteristics, as for example, that only affects the insect which pest wants to be eradicated, not affecting any component of the environment, as do the pesticides and insecticides that are toxic compounds. In addition, this technique is more effective when the density of insects in the pest is low, and it can be used together with other methods, as for example pesticides or insecticides. This technique does not introduce non-native species into the ecosystem. The sterile insect technique has been successful in controlling a number of insect pests, including fruit flies, tsetse flies, moths, and mosquitoes. Several improvements have been done of the sterile insect technique, as for example, the selection of male insects. Some female insects transmit diseases, as for example the malaria female mosquito, or produce damage in the harvest, as the fruit fly female. Therefore, releasing only male sterile insects has great benefits. Molecular biology techniques can be used to select male insects, for example, incorporating a gene in the Y chromosome that confers resistance to a toxic compound. Once the males are selected, they are sterilized by exposure to ionizing radiation and are released into the environment. Another improvement of the sterile insect technique is what is known as inherited sterility or F1 sterility. This technique uses much lower and less debilitating doses of ionizing radiation. The male insects are treated with sub-sterilizing doses of radiation, and when they mate with wild females, the radiation-induced harmful effects are inherited by the next generation, which is sterile. At the same time, the lower dose of radiation used to induce this sterility increases the quality and competitiveness of the released insects. The technique is mainly used with lepidopteran pests, as for example moths and butterflies.